Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson I'm going to be talking about viewing 2D results in RAS Mapper. This is part 3 of a hopefully 3-part lesson on the topic. Check out parts 1 and 2 in the previous 2 lessons if you're interested in the other parts of viewing RAS Mapper results. Okay, so anyway, what I have on the screen here is where I left off. This is the first page of the last few topics. We're going to talk about creating static maps stored, plotting velocities, querying RAS mapper results, and so on. This is the HEC RAS 2D users manual, and I'm in viewing 2D and 1D/2D output results in RAS mapper. All right, what I have on the screen here is an existing project where I have a flight path from the previous lesson. All right, and then what we have here is a river reach. It is flowing in the westward direction. I've got my river center lines, my bank lines, some cross sections, terrain, and I also have results over here. By default, when a 2D flow model runs, the plan will generate a dynamic layer here for velocity, water surface, and depth. But if I click on results, let's see, if I click on results and go to manage result maps, I now have those different layers organized by plan. So I have my first plan with 3 layers. Here's my second plan that we're looking at with the same 3 layers. Of course, it looks like I've got specific time steps assigned to them right now. That's not a problem. If I want to edit that layer, I can do so by just clicking on the layer and then clicking edit map, making the changes there. Also from this interface, I can create new map layers by clicking add new map layer for this particular plan, and then filling out this dialog box right here, which is covered in detail in part 1. But I did want to point out that if I go ahead and create select one of these 2 radio buttons for generate for current view, that would give me a dynamic map layer that's just generated on the fly and interpolated using map values. And then down here is the stored to disk. This is considered the static values or the static map layers. I'm going to do a quick example for how to create a static map layer. So I'll click on hydraulics. I'm going to compute the depth. And then let's go ahead and select the specific time here. So let's just say, how about 20 o'clock, which is 8 p.m. And then click on raster based on terrain. And then that's all I need to do. I'll click add to map and then click close. Now it added this new record here, depth, on January 1st at 8 p.m. Now right now it says map is not created. So what I need to do is click on this compute/update stored maps. And then for whichever layers are selected, like right now it's just the one we created, but I can select all of the map layers for this plan. Go ahead and make that button click. After clicking that button, it computed and it looks like it's now ready for viewing. So I can go ahead and toggle off the other layers. And this is our depth map for this plan at 8 p.m. on the first day of the simulation. Okay, I'm going to go ahead and remove that map now, or that layer. I can either remove the layer or remove the layer and the source files, which are saved within the project directory. So I'll go ahead and do that just to keep things clean and then confirm I want to delete. All right, I'm going to turn the depth layer back on here. Next, I can view time series output plots and tables. So to do that, I'll just go ahead and select the layer and then right click anywhere on the map and plot time series. And I can go ahead and select the depth that way. This is the depth at that location over the 24-hour duration of the simulation. I can also look at the table data by clicking on table, and then here are the depth fields right here. I realize that it starts off very low, and that's just because I didn't have a sufficiently long warm-up period. So let me back up here. And so here's my river reach, and then let me expand a little bit to the right, and then, yeah, so it doesn't even get to the end of the reach because I think I'm only using 1 hour. I'm going to go up to run, unsteady flow analysis, options, and then computation options and tolerances, 2D flow options. Yeah, I only have 1 hour here for initial conditions. Let's go ahead and say 4 hours, and then also 4 hours for the 2D flow area, and then click OK. And then let me save this plan and then run it, and then look at the results and make sure we have a sufficiently long warm-up period for the water surface to not look wonky like that. All right, so the simulation is completed. Let's check out those results. Okay, good. So now this is the first time period, and then second, third, all the way through 24 hours right there. Okay, so that looks better. Let's go ahead and zoom in and look at those results again. So right click, plot time series, depth. Okay, so it still starts pretty low, but not as low as it was, less than a foot. Now it starts at about 3 feet, more or less. So table 2.7. Okay, that corresponds to the starting flow rate at the upstream boundary condition. If I want to look at these other values, I can do that as well. I do have to toggle them on though. So I got velocity and water surface elevation as well. I'm going to move those to the bottom though. So move layer, bottom, and velocity, move layer, and bottom. Okay, so I got the depth on top. Now I could right click, plot time series, and now I have those three variables: water surface elevation, depth, and velocity. Let's check out velocity now. Similar looking plot. And again, we can look at the table data if we want actual numbers. We can also toggle on the 2D flow area and get results for cells and cell faces. Okay, I got it figured out. What we want to do is select the 2D flow area, and then, I toggle it off the terrain layer, and then go ahead and click on a cell face, plot property table, and now we have the option to plot the face profile, the face area versus elevation, and so on, wetted perimeter. Let's go ahead and check out that area elevation. Okay, that's just a constant. I'm going to toggle that terrain off once again. Okay, and then let's check out maybe conveyance versus elevation, also pretty constant. These are the results from the simulation, so I can check out different cell faces. Most of them have some curvature to them. This is what we're looking at here is the plot of the 2D flow area, this particular cell face, and then the parameter that's being plot is conveyance versus elevation, and that's controlled from this drop down right here. So once you have this dialog box opened up, you can go ahead and view all the results you want to without having to close it and then open it back up. As you see here, we also have tabs for plot and table. All right, so I'm going to go ahead and close that. Another feature in RAS Mapper displaying 2D results is to plot particle tracing. So what that is the water particles and how they move in the simulation. I'm going to zoom in on the map, and then what I'm going to do is select the velocity layer. So I'm going to turn off the other two layers. I have velocity layer selected, and then click on this arrow button right here. This is the static velocity arrows. So right now I'm seeing the direction of flow. This is the vector, if you will, of the flow, where it shows you the direction and the magnitude. And if you wanted to change the symbology a little bit, then you can just click on the button up here. That's a little arrow and a gear setting symbol, where you can go ahead and change the spacing to larger spacing. That's too large, or to smaller spacing like that, as well as changing the color of the arrow, either black or white. You can also click on the particle tracing button, which is this one right here. Oops. Okay, let me turn off the first one. There we go. This is particle tracing. So you see the little dots or the white lines making their way. That's supposed to be individual water particles. There are settings associated with this map display as well. Oh, hey, look, there's some water going in to this little inlet here. That's interesting. So go ahead and open up settings once again. Now what we can do in particle tracing is change the speed. So this is a lot faster. This is a little bit faster. This right here is the slowest speed. Let me go ahead and change it back to about 1. That's the default, I think. Okay, the density, if I wanted to make it less dense, then I just toggle that down or up. And then width, so let's turn that up. This is wide. This is the smallest. And then lifetime, I believe, is how long it lasts. Oh, I can do different colors. Okay, so let's change that to 0 and then toggle off. Okay, so there's blue. That's like a green blue right there. Let's go ahead and make it red. So I'll go 255.00. All right, I thought I would be able to see that better. Let's see, what's yellow? Would that be these two? Okay, cool. And then I want to make that thicker. So there we go. Okay, it's really looking bad now, but that's how that works. There are some keyboard controls as well. So for instance, F5 will toggle it on and off. It's off, it's on, it's off, it's on. The plus and minus symbol will decrease or increase the speed. So faster is plus, and then slower is minus. And then also control plus and minus will increase and decrease the density. So here is control plus to increase the density and control minus to decrease the density. So that's just a few of the same settings that we can change in this dialog box, but having a little bit better control by using keyboard commands instead. Next up is profile lines. Let me turn the terrain back on here. Profile lines is a feature that you can draw using up here in profile lines. So go ahead and select check it on. I already have one profile line added right here. I'm going to add another one, maybe further upstream. Go ahead and click on the edit pencil and then just sketch that profile line across the river reach or wherever you're interested in. I'll just call this line 1. HEC RAS Mapper has the option for users to draw in these profile lines on the map that give a line name. Then you give the line a name like you just saw me do, and then you can use that line to plot whatever results are turned on underneath that line. So right now we have depth, water surface, and velocity that are values we can look at underneath this particular line. So let me go ahead and stop my edits, say yes. Then what I want to do is right click on the line and then select the profile, plot, detailed, or fast. Let's just go with fast. And now here are the different parameters. So if I'm interested in the velocity profile across that profile line, here it is. So I probably could have sketched the line a little bit better. The line itself shows the stationing here is about 750 feet long, but then the width of the river, at least the water surface at this particular time step, is about, well, maybe 600, almost 600 feet wide. And you can see how the velocity is basically zero, and then it increases to its maximum along the middle of the channel and then back down. And then we have table data. So this is the stationing. I don't know why you need all these points if the value is zero, but then further along we have the velocity right there. All right. The other options here for the profile line, like I said, it would be any of the values that I already have layers for data beneath that line. So terrain, water surface elevation, velocity, depth, and I believe there would be more variables here if I had layers for them. Next up is user-defined views. So if you have a number of specific hotspots that you're particularly interested in within your model, then you can go ahead and create a view to very quickly and easily navigate to those locations. For instance, if you're running a simulation and you need to return to RAS Mapper and look at a specific spot on the map, let's check out this little inlet right here and call this a view. Over down in the views menu, actually, hold on, what's it called? I need to toggle to the left here. Okay, views is what it's called. I'll go ahead and add this view. So just get the view in the RAS Mapper interface just as you like it. I like this, it's fine. So your X, Y, and Z values. Then go ahead and click the plus button. I'll call this V1 for view 1. Okay. It's saved right here as view 1. So anytime I want to return to view 1, say I zoom out and then mouse over here, I can just double click on this V1 or whatever I named the view, and boom, it takes me back to that specific view. And the last topic is background maps. So if you wanted to add a background map to your RAS Mapper, then you can do that by just going up to the projects menu and then add web imagery. It gives you a number of different options here. So I like Google Maps or Google Satellite. Let's try that one. Click OK. And then under layers, okay, there they are. Map layers right here. Oh, okay. So the Google map just popped into place here. We can see that inundation flooding, and that's pretty cool. So we could also replay the simulation and see which areas of land or suburban or urban areas get flooded out and at what times and what depths. So instead of seeing the terrain model, which is what we're used to right here, we can actually see the topography or whatever is the actual map that you bring in. So there's other types of web imagery as well. I'm not going to demonstrate anymore, but that's where you can go ahead, add them, and then toggle them on and off as you wish. All right, well, that was it for this lesson. It's the third and final lesson, third part of the viewing 2D results in RAS Mapper. We talked about time series output plots and tables, drawing profile lines, user-defined views, and background maps.